Welcome back, and this time we're going to cover a few performance optimization aspects of S3. If you recall from earlier in the course, this is the Animals for Life scenario. We have a head office in Brisbane, remote offices which consume services from the Brisbane office, and remote workers using potentially slower or less reliable services to access and upload data to and from the head office. So keep this scenario in mind as we step through some of the features that S3 offers to improve performance. It's not always about performance, it's often about performance and reliability combined. And this is especially relevant when we're talking about a distributed organization such as Animals for Life. So let's go ahead and review the features that S3 offers which help us in this regard. Now, understanding the performance characteristics of S3 is essential as a solutions architect. We know from the Animals for Life scenario that remote workers need to upload large data sets and do so frequently, and we know that they're often on unreliable internet connections. Now, this is a concern because of the default way that S3 uploads occur. By default, when you upload an object to S3, it's uploaded as a single blob of data in a single stream. A file becomes an object and it's uploaded using the put object API call and placed in a bucket. And this all happens as a single stream. Now, this method has its problems. While it is simple, it means that if a stream fails, the whole upload fails, and the only recovery from it is a full restart of the entire upload. If the upload fails at 4.5 GB of a 5 GB upload, that's 4.5 GB of data wasted, and probably a significant amount of time. Remember, the datasets are being uploaded by remote workers over slow and potentially unreliable internet links, and this data is critical to the running of the organization. Any delay can be costly and potentially risky to animal welfare. When using this single put method, the speed and reliability of the upload will always be limited because of this single stream of data. If you've ever downloaded anything online, it's often already using multiple streams behind the scenes. There are many network-related reasons why even on a fast connection, one stream of data might not be optimal, especially if the transfer is occurring over long distances. In this type of situation, single stream transfers can often provide much slower speeds than both ends of that transfer are capable of. If I transfer you data with a single stream, it will often run much slower than my connection can do and your connection can do. Remember, when transferring data between 2 points, you're only ever going to experience the speed, which is the lowest of those 2 points. But often using single stream transfer, you don't even achieve that. Data transfer protocols such as BitTorrent have been developed in part to allow speedy distributed transfer of data, and these have been designed to address this very concern. Using data transfer with only a single stream is just a bad idea. Now, there is a limit within AWS. If you utilize a single put upload, then you're limited to 5 GB of data as a maximum, but I would never trust a single put upload with anywhere near that amount of data. It's simply unreliable. But there is a solution to this, and that solution is multi-part upload. Multi-part upload improves the speed and reliability of uploads to S3, and it does this by breaking data up into individual parts. So we start with the original blob of data that we want to upload to S3, and we break this blob up into individual parts. Now, there is a minimum. The minimum size for using multi-part upload is 100 MB. So the minimum size for this original blob of data is 100 megabytes. You can't use multi-part upload if you're uploading data smaller than this. Now, my recommendation is that you start using this feature the second that you can. Most AWS tooling will automatically use it as soon as it becomes available, which is at this 100 MB lower threshold. There are almost no situations where a single put upload is worth it when you get above 100 MB. The benefits of multi-part upload are just too extensive and valuable. Now, an upload can be split into a maximum of 10,000 parts. parts, and each part can range in size between 5 MB and 5 GB. The last part is left over, so it can be smaller than 5 MB if needed. Now, the reason why multi-part upload is so effective is that each individual part is treated as its own isolated upload. So each individual part can fail in isolation and be restarted in isolation rather than needing to restart the whole thing. So this means that the risk of uploading large amounts of data to S3 is significantly reduced. But not only that, it means that because we're uploading lots of different individual bits of data, it improves the transfer rate. The transfer rate of the whole upload is the sum of all of the individual parts. So you get much better transfer rates by splitting this original blob of data into smaller individual parts and then uploading them in parallel. It means that if you do have any single stream limitations on your ISP or any network inefficiencies, by uploading multiple different streams of data, then you more effectively use the internet bandwidth between you and the S3 endpoint. Now next I want to talk about a feature of S3 called accelerated transfer. To understand accelerated transfer, it's first required to understand how global transfer works to S3 buckets. Let's use an example. Let's say that the Animals for Life organisation has a European campaign which is running from the London office. For this campaign, they'll need data from staff in the field. And let's say that we have 3 teams dedicated to this campaign, one in Australia, one in South America, and one on the west coast of the US. Now, the S3 bucket, which is being used by the campaign staff, has been created in the London region. So this is how this architecture looks. We've got 3 geographically spread teams who are going to be uploading data to an S3 bucket that's located within the UK. Now, it might feel like when you upload data to S3, your data would go in a relatively straight line, the most efficient line to its destination. Now, this is not how networking works. How networking works is that it is possible for the data to take a relatively indirect path, and the data can often slow down as it moves from hop to hop on the way to its destination. In some cases, the data might not be routed the way you expect. I've had data, for instance, routed from Australia to the UK, but taking the alternative path around the world. It's often not as efficient as you expect. Remember, S3 is a public service and it's also regional. In the case of the Australian team, their data would have to transit across the public internet all the way from Australia to the UK before it enters the AWS public zone to communicate with S3. And we have no control over the public internet data path. Routers and ISPs are picking this path based on what they think is best and potentially commercially viable. And that doesn't always align with what offers the best performance. So using the public internet for data transit is never an optimal way to get data from source to destination. Luckily, as solutions architects, we have a solution to this, which is S3 transfer acceleration. Transfer acceleration uses the network of AWS edge locations, which are located in lots of convenient locations globally. An S3 bucket needs to be enabled for transfer acceleration. The default is that it's switched off, and there are some restrictions for enabling it. The bucket name cannot contain periods, and it needs to be DNS compatible in its naming, so keep in mind those 2 restrictions. But assuming that that's the case, once enabled, data being uploaded by our field workers, instead of going back to the S3 bucket directly, it immediately enters the closest, best performing AWS edge location. Now, this part does occur over the public internet, but geographically it's really close and it transits through fewer normal networks, so it performs really well. At this point, the edge locations transit the data being uploaded over the AWS global network, a network which is directly under the control of AWS, and this tends to be a direct link between these edge locations and other areas of the AWS global network, in this case, the S3 bucket. Remember, the internet is a global, multi-purpose network, so it has to have lots of connections to other networks and many stops along the way where traffic is routed from network to network, and this just slows performance down. Think of the internet as the normal public transit network when you need to transit from bus to train to bus to bus to get to a far-flung destination. The normal transit network, whilst it's not the highest performance, is incredibly flexible because it allows you to get from almost anywhere to almost anywhere. The internet is very much like that. It's not designed primarily for speed, it's designed for flexibility and resilience. The AWS network, though, is purpose-built to link regions to other regions in the AWS network. And so this is much more like an express train, stopping at only the source and destination. It's much faster and with lower, consistent latency. Now, the results of this in this context are more reliable and higher performing transfers between our field workers and the S3 bucket. The improvements can vary, but the benefits achieved by using transfer acceleration improve the larger the distance between the upload location and the location of the S3 bucket. So in this particular case, transferring data from Australia to a bucket located in Europe, you'll probably see some significant gains by using transfer acceleration. The worse the initial connection, the better the benefit by using transfer acceleration. Okay, so now it's time for a demonstration. In the next lesson, I just want to take a few moments to show you an example of how this works. I'll want to show you how to enable the feature on an S3 bucket and then demonstrate some of the performance benefits that you can expect by using an AWS provided tool. So go ahead, finish this video, and when you're ready, you can join me in the demo lesson.